Okay, so welcome to the Delta Conveyance Project Informational Webinar on Fisheries. My name is Juliana Burkhoff. I work for Ag Innovations and I'm facilitating this webinar this evening. Before we get started, I'll walk through how to participate in different ways throughout the evening. So first, let me walk through how to get into the Spanish language translate channel and access the translated presentation. I'll then turn things over to Reina Rodriguez with Linguistica to go over the Spanish translation logistics for this evening, including the information I'm about to provide. So to switch to the Spanish channel, click on the interpretation icon at the bottom of your screen and choose Spanish. If you want to view or download the translated version of the presentation, go to the informational webinars page on the Delta Conveyance section of the DWR web page. There's the information there on your screen on how to find that information. Once you're on that page, go to the information in Español section where you'll find a link to the presentation under the header for this evening's webinar. Reina.
Muy buenas noches a todos, bienvenidos a la reunión. Esta reunión será interpretada de manera simultánea a través de la reunión. Le invitamos también a que haga preguntas y respuestas en su lenguaje por medio del chat o durante la oportunidad de preguntas y respuestas también va a poder hacer su pregunta en español. Para accesar la interpretación esta noche, si está en una computadora, a favor de seleccionar el icono que aparece un mundo abajo de su pantalla. Después de que seleccione el icono, va a seleccionar su lenguaje de español y le invito a que ponga el audio original en silencio para que de esta manera solamente escuche la reunión en español y no escuche un eco. Si usted está uniéndose por medio de un teléfono o un iPad, sus funciones van a ser un poco diferentes. Usted va a buscar los tres puntitos que están en su pantalla. A veces están en la parte superior a mano derecha, a veces en la parte inferior a mano derecha, dependiendo del aparato. Selecciona los tres puntitos y luego va a elegir lenguaje. Y después de que elija lenguaje, usted va a poder seleccionar español y va a poner el audio original en silencio y por último va a seleccionar el icono que dice listo y de esta manera usted va a poderse unir al español. Cualquier pregunta o comentario, siéntase libre de dejarnos saber si está teniendo problemas con la interpretación. Si tenemos aquí a nuestro asistente técnico, a Ryan, le pueden enviar un mensaje y de esa manera él les puede guiar y ayudar y asistir con interpretación. Bienvenidos a la reunión. Y también si usted quiere unirse y bajar las diapositivas o la presentación en español, le invitamos a que vaya a la página de internet de DWR, donde ellos tienen los recursos en la sección de español para que usted pueda descargar la presentación del día de hoy y que la pueda seguir junto con nosotros. Tenemos el sitio de internet donde usted puede ir para accesar la interpretación en la pantalla. Y si por cualquier razón no se puede unir a la interpretación, favor de dejarnos saber y tenemos otras opciones disponibles para que usted se pueda unir. Gracias.
Thank you, Reina. So a few more logistic items before we get into the format and the agenda. So this webinar is being recorded and closed captioning is also available. You can click on the CC icon at the bottom of your screen and click enable. The presentations for this evening are also available on the DWR website, and they were also sent out this afternoon if you signed up. So to view or download, go to the informational webinars section of the DWR page, and you'll see Delta Conveyance, and then you find on that page, scroll down to the topics, schedule and registration part of the page, and you'll see a link to the presentation under the header for that webinar. So, and afterwards, DWR will also have a video that's available for this on the DWR website. In a moment, I'll turn to Carrie Buckman with the Department of Water Resources, who will talk more about the purpose of these webinars. But first, let me describe the webinar format and the agenda. Tonight, you'll hear an overview of a series of technical information, and you'll have an opportunity to ask clarifying questions on that information. Presentations will be given on the California Environmental Quality Act, CEQA, that process, fish and aquatic resources analysis, and fish screen considerations and operational criteria. If you have any questions during any part of the presentation portions, you can submit them through the Q&A portion on Zoom. You'll see a Q&A feature. Hit that Q&A icon at the bottom of the screen and type your questions into the box. Following each presentation, there'll be a bit of time for us to address those written questions. And if we don't get to all of them tonight, since there's so many people participating, DWR will try to answer those written questions during the verbal Q&A section at the end of the webinar. Following all the presentations, there will be an opportunity to ask verbal questions by raising your hand and click raise hand icon at the bottom of the screen. I'll do my best to call on people in the order in which they raised their hands. So if you're also participating by phone, you raise your hand by pressing 9. That raises your hand, and then you press 6 to unmute yourself. So either through Zoom or through phone, at the end, there'll be a question and answer session. If you have a question that DWR doesn't get to tonight, then you can email deltaconveyance@water.ca.gov, and DWR will be taking notes on all these different questions, and they'll respond with a frequently asked questions document that they'll put on the webinar. So I hope that makes sense for you to ask written questions during the presentations, and then to ask verbal questions at the end of the presentations. As a reminder, this isn't a formal California Environmental Quality Act presentation. It's not a public input opportunity. There'll be several opportunities for public input once the draft environmental impact report has been released, which is scheduled maybe mid-2022 to be released. These webinars are really for you to learn about the technical information so that when the environmental impact report comes out, you'll already have some background on the operations modeling, the fish modeling, climate change, and environmental justice, which are to come. So please focus your questions on clarifying information that will help you review that draft EIR. So let me turn now and introduce Carrie Buckman. Carrie Buckman is the Delta Conveyance Project Environmental Program Manager with the Department of Water Resources. She'll present information about the proposed project, including details on the schedule, the planning process, and future opportunities for public participation. She'll also provide some information on the California Environmental Quality Act process and how these webinars relate to that process. Carrie.
Thanks, Juliana. So first, I really want to start with a welcome and a thank you for everyone for participating in this meeting. I know that everyone has other ways to spend their time, and we really, really appreciate that you are spending your time here with us this evening. I'm going to start with some introductory material about the purpose of these webinars, a quick project overview, and some information about CEQA. For those of you that participated in the last webinar, this will be a bit of a repeat, but we'll try to keep this short to move on to new content. The purpose of these informational webinars is to provide some background on technical topics well in advance of the release of the Draft Environmental Impact Report, or EIR. The goal is to share the methodology we will use and the assumptions we will make when evaluating the environmental effects of the project. We know that this effort, these issues can be very technical and complicated, and so we're hoping that these informational webinars will help clarify these topics and help members of the public in reviewing the draft EIR when it becomes available next year. We know and understand that there are very strong sentiments about this project and that there is a high interest in making those feelings known. As Juliana said, these meetings are really meant to provide an opportunity to ask questions to clarify our approach to the environmental analysis. I would encourage you as much as possible to take advantage of this opportunity to ask your questions of our technical experts and to preserve as much of the Q&A portion of the meeting for those types of clarifying questions. There will be a formal review period once the draft EIR is published and many opportunities for public comment. We're still in the process of developing the draft EIR, so we don't have results to share. We're really focused on methods, assumptions, background information that will help when the draft EIR is ready next year, but the results will be included in that draft EIR in 2022. I also want to note that that we know that there is a high degree of interest in many water issues right now, including drought, climate change, and a lot of other serious water-related issues facing California. Our focus tonight, though, is specifically on providing information about the Delta Conveyance Project. So we will not be able to address as many other topics. We'll really be trying to keep our Q&A and our discussions focused on Delta Conveyance. So I wanted to start with the fundamental purpose of the Delta Conveyance Project, the basic reasons that DWR is considering this project. So the purpose is to modernize the aging state water project, SWP infrastructure in the Delta, to restore and protect the reliability of SWP water supplies in a cost-effective manner, consistent with the state's water resilience portfolio. Generally, we want to try to protect SWP infrastructure in the face of many challenges, which are reflected in our objectives. So we want to try to address sea level rise and climate change, minimize water supply disruption due to seismic risk, protect water supply reliability, and provide operational flexibility to improve aquatic conditions. So this slide gives us a quick overview of the proposed project and the alternatives that we're considering. So the proposed project would include two new intakes in the North Delta, each with 3,000 CFS or cubic feet per second capacity, and then a tunnel to connect those new intakes to the South Delta. That tunnel could follow one of two corridors, either the central corridor shown in orange or the eastern corridor shown in blue. The eastern and central corridor would terminate in the south at a new pumping plant that would pump water up into a southern forebay. And from there, it would travel into the existing Banks approach channel and through Banks pumping plant. As you can see in green, we do have another alternative called the Bethany alternative, which would follow the eastern corridor to sort of partway down and then veer a little bit further south. And rather than terminating into a pumping plant and then into a southern forebay, there would be one pumping plant and it would go directly into Bethany Reservoir. The need for that southern forebay is largely driven by the fact that there would be two pumping plants that would need to work together. And so there would need to be a regulating body in between to regulate flows. This Bethany alternative would only have one pumping plant, a new pumping plant that would pump water up into Bethany Reservoir. So without that need to regulate flows, we would eliminate the need for that large southern forebay, which is really sizable and has potential to reduce impacts. So this reflects our current project schedule. We are working now towards a public draft EIR in mid-2022. The Army Corps of Engineers is leading the National Environmental Policy Act process, and they are working on a draft environmental impact statement on a similar schedule. They will be two separate documents. We're looking at a public review period next year, middle of the year, and then working to finalize the documents and develop decision documents in late 2023. We're also working on a variety of other permitting efforts that will terminate at the end in 2024. So now I'm going to talk a little bit about the overall CEQA process. Before we launch into this, I did just want to remind everyone that CEQA is a really long and complicated process, and we're really providing just a very brief overview here so that you'll understand the context that we're working in. But I do want to encourage people who are interested, we do have a longer video that describes the CEQA process on our website. So that's there to provide more information. Tonight, I'm really just providing a little bit of context and foundation for the rest of the meeting. CEQA is a requirement for all public agencies subject to the jurisdiction of California to analyze impacts of a proposed project prior to approval. So the idea is to evaluate what could happen to the environment in relation to the proposed project. So the idea is to disclose potential significant environmental effects, identify ways to avoid or reduce significant environmental impacts, prevent environmental damage if feasible by requiring implementation of alternatives or mitigation measures, foster interagency coordination and public participation, and show that the agency is considering environmental implications of actions prior to making a decision. So we are developing an environmental impact report under CEQA. And the purpose of that is to provide really a lot of information. It is a disclosure document to provide information about a project's potential significant environmental impacts and ways to avoid, minimize, reduce, or compensate for those impacts. The EIR will demonstrate that the environment is being considered and develop ways to prevent environmental damage if feasible. So these are typical contents of an environmental impact report. There's typically a project description, a description of the existing environmental setting, which is used as the baseline for comparison, a discussion of significant environmental impacts, direct, indirect, and cumulative impacts, Where there are significant environmental impacts, there will be a discussion of potential mitigation measures to reduce those effects. There's also a discussion of growth-inducing impacts, alternatives, a reasonable range of alternatives compared in meaningful detail, and a list of organizations or persons consulted. And this shows the overall process that we're going through. And right now, highlighted in yellow, we are working to assess potential impacts and identify mitigation where appropriate. And one of the things I really wanted to highlight on this slide is that there are a couple of opportunities, primary opportunities for outreach and input from the public. The first was during scoping, which is highlighted in orange on the first row. And the next one will be after the draft EIR is released. There will be a public circulation of that draft for comment and a series of public meetings to provide information and hear comments back from the public about the process and the document. So I wanted to just mention that here because similar to what I was saying earlier, there will be plenty of opportunity for comment on that impact and mitigation analysis, but since it isn't done yet, we're really focusing more on the background information tonight. And so with that, Juliana, I will turn it back to you.
Thanks, Carrie. So let me remind people that this webinar is being recorded. You'll be able to find the information, the presentation on the DWR website right now, and the whole webinar is being recorded and you'll be able to find it. Those of you who want to provide questions, asking clarifying questions, several of you have found the Q&A part. That's where you type in questions. We won't go to verbal questions until the end of the evening. Thanks. So the Q&A is open. Be sure and type your questions in there. Let me turn now to Mike. Mike is going to, Mike Hendrick is a senior biologist with ICF, and he's going to give a presentation on the fish and aquatic resource analysis for the draft environmental impact report. And then we'll have a chance to ask questions of Mike after the presentation. Mike.
All right, thank you. And thanks, Carrie, for the great introduction on CEQA. Not easy to do over the course of just a few slides. And again, my purpose today is to really just do an overview of the fisheries and aquatics analysis and its nexus with the CEQA process. So the purpose of the analysis is to comply with the CEQA requirements, as Carrie kind of did an overview of those in the previous slides. The CEQA document will ultimately be utilized by responsible agencies to support permit development and decisions. An example of this will be the California Department of Fish and Wildlife and their development of incidental take permit for state-listed threatened or endangered species. An example, a part of this process would ultimately end in a take provision for a listed species like longfin smelt. Tonight, I will be providing an overview of the fisheries and aquatics resource analysis. This will include, but not be limited to, some basic baseline information. I'm going to go over potential species stressors, go over potential fish and aquatic species that will be studied in the study area. Going to go do a brief introduction to the analytical methodologies, and this will include a brief introduction to the modeling efforts. And then additional presenters are going to be discussing further potential fish screens and some preliminary project operations that are related to fisheries. This is sort of intended to give everyone a biology 101, again, to kind of set that baseline for where the analysis will be leading ultimately for the public draft EIR for folks to review. All the species analyzed will exhibit the following during their life history. They will all go through spawning, which is the act of females laying eggs in the water and then the male fertilizing the eggs. There will be rearing. This is essentially the act of a juvenile as it matures into an adult. Depending on the species, they all have different migrations. I will have a slide to demonstrate an example of this later. Some species are anadromous, meaning they're born in freshwater, migrate to ocean for some amount of time, and then return to freshwater to spawn. Examples people are familiar with include the salmon. Some fish are semi-anadromous, meaning they're born in freshwater and migrate to low salinity or brackish water as adults. An example of this would be delta smelt. And then some fish are resident, and these do not migrate to the ocean and remain in freshwater. Examples are some of the native minnows, such as Sacramento hitch and hardhead, and they typically are found in the upstream watersheds. All the fish analyzed are either going to be native or non-native. Native are defined as species that originated naturally in a specific location, river, stream, lake, etc. Examples would include the delta and longfin smelt. And then we have some non-native species we'll be looking at. And these are species that originated in a location other than the one that was introduced. And examples would include striped bass. Of the fish analyzed, some are state and federally listed. Examples would include spring run Chinook salmon, winter run Chinook salmon, while some are of commercial or recreational importance, such again as the striped bass. The analysis will include an environmental setting. I'll be showing some slides on this a little bit later to give some more specificity for the Trinity system in the Central Valley. Analysis of impacts that could result from construction, operation, and maintenance of the project will be included. Proposed mitigation measures to reduce effects of potentially significant impacts, that will be included in the analysis. So here's a general overview of the study area. If you look up further north at the top of the screen, you see that's where the Trinity River Basin is, and this includes Trinity and Lewiston reservoirs in the lower Klamath River. Part of the study area also includes Sacramento River, including Shasta and Keswick reservoirs. We'll be looking at Clear Creek, Whiskeytown Reservoir, Feather River, American River, Stanislaus, and San Joaquin. This study area also includes the State Water Project and the Central Valley Project export service areas. Looking at the map to your right, the area in sort of the forest green designates the State Water Project, and the area sort of in that yellow-orange are the Central Valley Project export areas. So the species to be considered for analysis in the study area are selected for analysis based on importance, vulnerability, and potential to be affected by construction activities and changes in State Water Project and Central Valley Project operations to be implemented under potential project alternatives. Species of management concern will also be analyzed, and this includes species listed by state or federal agencies as endangered or threatened. Again, this includes examples such as longfin smelt, spring run Chinook salmon. Also to be looked at are species of special concern as identified by California Department of Fish and Wildlife. These fall into categories of critical, high, or moderate importance. Some examples of these include fall run Chinook salmon or late fall run Chinook salmon. I think the next slide focuses in a little bit on the Trinity River region. And this is just to give the viewers a little bit better idea of, of what this region and the species we might potentially analyze as part of the CEQA process. And the next slide, I believe, focuses it on the Central Valley region. Same concept. The species that you see on the left, are not necessarily all going to be analyzed, although most of them probably will, but these are the species that we are considering right now for potential analysis. These will be refined as the CEQA process moves forward. The following, this is a list of potential stressors to the fish and aquatic species. Numerous studies have pointed to various stressors that have negative impacts to aquatic and fish species, including those potentially analyzed as part of the CEQA process. On the left, I'll go ahead and read them. We've got contaminants, entrainment, habitat quality and quantity, invasive species, fish passage and fish stranding, physical harm and noise, predators, water temperature, and water quality. And again, I'd like to emphasize this is not necessarily a complete list, but these are some of the key ones that we are showing on the slide tonight. Earlier, I had mentioned all species exhibit some sort of migration pattern. The ones that people are most familiar with are the salmon, recognizing that they are born in freshwater, migrate to the ocean, then come back to freshwater to spawn. This is the spring run Chinook salmon. I understand that probably not everyone can read the colors and what they all mean, but I do want to just go over a couple of aspects on this slide in a little more detail. The black color is what is the historic range of this Central Valley spring run Chinook salmon. The sort of dark blue is the current range of the Central Valley spring run Chinook salmon. And then some of the other colors, such as the red and the baby blue, show areas where they spawn. Again, hopefully people can read all those details. All the species that we analyze exhibit a life cycle of one kind. Again, we chose to highlight the Central Valley spring run Chinook salmon for this presentation tonight. Spring run Chinook salmon initiate upstream migration in the Sacramento River during the spring months and into the early summer. Adults will hold in the Sacramento River watershed, including the tributaries, until the fall when they will spawn. And then the juveniles will start to outmigrate from the Sacramento River watershed. This means moving from freshwater down towards the ocean the following late winter and spring. And the next slide gives a little more specificity to this life cycle for the Central Valley spring run Chinook salmon for the Delta specific. Both the adults and juveniles are present during the late winter and into the spring. Adults are on their way upstream while juveniles are heading towards the ocean. Fish and aquatic resource analyses will be conducted both qualitatively and quantitatively. Quantitative analysis involves quantities, therefore numbers. Example would be numerical data that is available through various models, methods to estimate a potential effect of change, any type of change. This could be an operational change, etc. Qualitative data is descriptive, for example, area of origin for salmon, Feather River or American River. This is qualitative data is generally used when more numerical data may be less available and a determination of effect or change is based on best available information and best professional judgment. As part of the analysis, we will be looking at construction activities that potentially affect in-water environment. And this again is construction of intake facilities, forebay emergency spillway, bridge crossings, and other associated activities. This also looks at potential operation activities. We'll be evaluating potential life stages and types of effect from operations under each potential alternative. And there will also be associated and needed ongoing maintenance activities that will be evaluated. Here is just to give kind of a basic overview of the draft EIR modeling framework. There are various models that will be utilized as part of the analysis. These models all require baseline information or input data. Examples include climate change hydrology, sea level rise, and there are a slew of others. This information forms the basis of what is known as CalSIM-3. CalSIM-3 is a model that simulates operations of the State Water Project and Central Valley Project and associated infrastructure. CalSIM-3 plays a key role and is utilized as a base and as a foundation model, for the development of additional models that analyze potential in-delta and upstream effects to fish and aquatic species. And the diagram on your right is sort of a flow chart to give an idea of how this process looks and how any one model is dependent on others. Towards the end of the analysis for fish and aquatics, we take all the data that we have based on the above slides, and they're ultimately compared to what's known as thresholds of significance. These thresholds examples include, does the proposed project substantially reduce the habitat of a fish or aquatic species? Another example is, does the proposed project substantially reduce the number or restrict the range of an endangered, rare, or threatened fish aquatic species? Thank you.
Great, thank you so much, Mike. DWR will have a few minutes now to address some of the questions that have come in the written question and answer period. Let me also introduce Maren Greenwood, Senior Fish Biologist at ICF, who will also be able to help answer some of these questions. Carrie?
Thanks, Juliana. So just a couple of quick clarifications from my presentation. I think that there was a little confusion about the alternatives figure that I had where people thought that we may be considering a 2-tunnel project. So I really wanted to clarify that we are only considering a 1-tunnel, single tunnel project. We're looking at multiple potential alignments, but we would in the end only select one alignment. Also, someone asked about growth-inducing impacts. So CEQA asks that project proponents consider the potential to cause growth or induce growth. So they're looking at whether a project would induce substantial unplanned growth that could then have environmental effects. So we will be considering the potential for that. So Mike, a question for you that came in. Right now, the conditions for Chinook salmon, both spring and winter run particularly, are very much at risk. Can you talk a little bit about how you consider that as part of the existing conditions, as part of the basis for your analysis?
Sure. Yeah. We use best available science for all of our analysis that goes into fish and aquatics as part of the CEQA effort. That will include data up to, there's the reality of the drought situation right now. there is the reality that some species are doing better than others. So yes, all that data will be considered. And ultimately, I'd like to remind people, you know, I think it was my first or second slide, the CEQA process will form the basis for other agencies that will ultimately permit any proposed project or any project that occurs. So this will all have to go through National Marine Fisheries Service, U.S. Fish and Wildlife Service, California Department of Fish and Wildlife, and others before ultimately anything is permitted. So, you know, the concerns of the realities of the fish right now, drought, whether it'll continue going, that will all be considered as part of the analysis.
Thanks. And then we also received a question about how much outflow of fresh water is needed to achieve safe water quality for the aquatic life in the system. And I did want to just mention that that effort is being led through the State Water Resources Control Board through their potential considerations of an update to the Bay Delta Water Quality Control Plan. So that is something where, regardless of what standards are in place, any Delta conveyance project would have to meet them. Those standards are being established by the state board. So I think, Juliana, we can go ahead and move on. Thanks.
Keep typing in your questions. And now let's turn to Gardner Jones, who's the Aquatic Resources Program Manager with the Department of Water Resources, who'll give a presentation on the operational criteria.
Hey, Juliana, I think actually we're going to Phil Ryan next.
Oh, first,
for intake
okay,
screens.
sorry.
Yeah.
Thanks. We're going to Phil Ryan with the Engineering Design Manager with the Delta Conveyance Design and Construction Authority. And Phil will present some information on fish screens. Thanks.
Okay, thank you. Good evening, everyone. You hear a lot about the intake structures and other things associated with fisheries in the river. The intake structures are the main physical interface between the fisheries resources in our rivers and the project. So I thought I'd give you a quick overview of just what really is an intake, so that you have a feel for that as you hear discussions about that. So you can see on this picture on the slide here, it's a rendering of a typical intake. The river is along the bottom, and there is an intake structure with fish screens right in the center along the bottom, that concrete structure, and the fish screens would be underwater. You can see a log boom out in front, and then these walls on either end that curve back in to give the structure a smooth transition into the river system. Water flows from the river through the intake screens, through the structure, through some pipes with gates on it into the sedimentation basin. Main reason for the sedimentation basins is there's often a lot of sediment carried in the rivers, particularly in the high flow periods in the winter. And going into a 40-mile tunnel system, we want to settle that sediment so it doesn't settle in the tunnel system where it's virtually impossible to get at. There's a flow control structure at the back of the sedimentation basins to help maintain sedimentation basin levels for that control. And then the flow goes into the tunnel and outlet shaft that leads down to the tunnel system. There's also sediment drying lagoons that are used about once a year during the summer to remove the sediment from the basins to dry it out to be trucked off. And the particular intakes on this project are along Highway 160 and the Sacramento River Project levee for flood control. And both of those items have to be maintained continuously for the passage of traffic and for flood protection for the people who depend on that levee. So the DCA went through an extensive analysis of virtually all of the types of intakes that are available for diverting water essentially in the world. And we settled on bank structures, which are the structures you see in the photos here that are, rather than being in the middle of the river, they're on the edge of the river. So they're called on bank. And then two different screen types. The vertical plate screen type shown on the left, that's the Freeport project that some of you may be familiar with. And then a T-screen, cylindrical T-screen system on the right. And that's essentially, they're just two different types of screens. They're both highly effective and have both been shown to provide very high level protection to fish species at the intakes themselves. I'm going to go through each one of these to make sure you really have a good understanding. So this is a 3D rendering of the vertical flat plate screen facility. Darker brown square panel at the bottom beneath the tan panels, that's the fish screen. There's solid panels above. So as water is induced to flow through the structure, it only flows through those gray or those darker brown panels at the bottom, flows into the open structure, and then flows through those box culverts you see into the sedimentation basins. So a little more of a close-up view of that. You can see again, the brown panels at the bottom under the tan panels, and they slide in those gate guides you see up on the upper left photo there. So the screens slide down those panels and they sit at the bottom of the structure, and then the screen material you can see on the right. That's a screen material established by the regulatory agency suitable for salmonids and delta smelt and other juvenile delta species. So these screens have to be cleaned because they grow mainly certain types of algae on them. That's, you know, biofouling of the screen. So they are swept on a regular basis, and they're periodically pulled up and cleaned off with high pressure jets. So on the left in the red dashed circle, you can see that's the screen cleaning mechanism. And that thing right down at the bottom over the brown panel is what's shown in white there in the middle. That's essentially, I like to call it a giant toothbrush. The brushes are along the bottom half there. You can see a picture of those brushes down in the lower right. And then in the upper right, you can see how the mechanism is attached to the structure. And if you go back to the far left, you can see that facility kind of hanging down there over the brown thing. And that motor up on the top pulls a cable system that drives that brush back and forth. And there's a counterweight system to make sure the brush stays in contact with the screens. Now, as opposed to that one, we'll switch to a cylindrical T-screen facility. Now you can see the cylindrical T-screens, they're at the bottom of the structure and essentially in the same location where the darker brown panels for the vertical plates would have been. Instead of flowing into an open structure, the T-screens feed directly into a pipe that flows directly through into the sedimentation basins. Again, a close-up of that same structure, you can see most of the T-screens are in the raised position. You can see the one in the middle down in the lowered position. That's a during construction photo of that particular intake. And then in the white on the left, that's the exact configuration that would be proposed for the Deltic Advance project. Again, the screens slide down that same kind of rail system, and then they have solid panels above them so that flow only goes through the screens. These screens are cleaned in a slightly different method. There's a submersible motor inside the screens, and each side of the screen cylinders rotate. The brushes are fixed. There's one on the inside and one on the outside, and they rotate to keep the biofouling off of the screen material. It's essentially the same screen material. You can see it in the upper right there, and you can see how good of a job that these particular cleaning mechanisms do. Even that particular picture is in a screen that's fouled with invasive mussels, which are, you know, notoriously difficult for intakes. You can see what a good job the screen cleaners do even on that type of a situation. So we did a comparison between the two screens, and like I said, they're both very effective. They're both used quite a bit, so you kind of can't go wrong from a protection perspective from both of them. So some other things have to come into play in trying to decide between them. So the cylindrical T-screens, they result in a shorter structure due to the calculations that go into determining their length. You have individual flow control over each screen unit, so you get better flow control, so the control of uniformity and maintaining the exact required and allowed diversion rates. Like I mentioned, they have better screen cleaning. Those brushes systems in the rotation work better than the giant toothbrush. Because they're underwater, completely submerged, they really don't make any noise. So that's a kind of a big advantage to them. And even though they do have motors in them, they are easier O&M because there's just less things to mess around with. And the motors are, you know, they're heavy duty motors and they are highly dependable. We don't have to jet sediment from inside that structure. But at a slight disadvantage, they do protrude into the river. So there's possibly more debris collection and potential for damage. And then for those of you who understand refugia for fish management, as they pass the structure, you can provide refugia on these structures without adding length. Another interesting feature for these is the primary supplier of these types of screen is actually a manufacturing firm that is in the Delta. On the vertical plate screens, obviously they're a little longer. You can get effective flow control on them, but in the T screens, you can get it by 100 CFS sections. And on the vertical plate screens, it's on larger 500 CFS sections. Like I mentioned, they're slightly less effective screen cleaning. The giant toothbrush has some striping issues, and there's a lot of O&M required to keep the screen cleaners really doing a good job. Because of the pulley systems and stuff that's above water in some cases and under some conditions, they can be noisy, and they take O&M to keep them from being noisy. So it's more frequent to pay attention to that particular facility. And like I noted on the T screens, there is sediment jetting required here, which isn't on the others. An advantage, though, is the screen sections are flat with the structure face, as you notice from the pictures. But the screen cleaner is still susceptible to a small amount of damage. And if you add refugia to these, because it's one screen panel along to the next, it will add additional length for fish passage. So in summary, in evaluating all these, the recommendation is to utilize the cylindrical T screens. There's a shorter in-river diversion structure. They have better screen cleaning with less O&M to keep it that way. We have better flow control over the range of diversion flows. There's no noise, and they have an excellent track record in providing fish protection and actual performance. So that concludes my section to help introduce you to the intakes and the types of screens that were considered.
Thank you so much. Please, if you have any written questions about the screens, please type them into the Q&A part. Carrie, do you want to go through those questions?
Sure. Phil, could you talk a little about the differences between the capital and operating costs between vertical flat plate and T screens?
The capital costs are roughly the same because the screens themselves probably cost a little bit more than the vertical plate screens, obviously, because there's a whole unit there, but the structure is shorter. So, and when you make the structure shorter, we're talking about cofferdam sizes and piling and the whole thing. So in our estimations, they're roughly the same in capital costs. In O&M costs, they're also very similar. The O&M costs of these things are very low. The motors that you use to turn the screens are, I want to say they're less than 10 horsepower. They're pretty small. And then on the vertical plate screens, you have motors that are also small, but that run the giant toothbrushes for screen cleaning. And you also have to have pumps to pump for sediment jetting. So I would say that the actual like power costs are probably slightly more for a vertical plate screen, but not significant in the overall operation of a facility. And then I think the fact that they require less presence and manpower to keep them really functioning at in top notch, I think that the labor would favor the T screens as well.
Thanks. And so for the alternatives that we're considering alternatives that range between 3,000 and 7,500. So we're looking at 1, 2, or potentially 3 intakes, and sometimes they're different in size. Could you just quickly explain if there are any differences in the fish screens when we're looking at smaller or larger intakes?
The fish screens are identical for the different systems. Now the sizes of the structures might be slightly bigger, but the screens themselves, we have set everything up for the vertical plate screens in 500 CFS units. So for a 1500 CFS intake, there'd be 3 of them. So that'd be half the length of a 3000, which would have six units. With the T screens, they're each 100 CFS. So there'd be 15 T screens on a small one and 30 on a large one. So the structures themselves are almost identical. They're just the layout and fitting them and the overall capacity is the only difference.
Thanks. And then could you explain what refugia means?
So refugia, it might be better to turn this over to some of the biologists, but it's been described to me as a fish hotel. So as the fish are traveling past the screens, they have a place to stop over and rest before they continue their quest, mainly downstream for salmonids. And these are areas they can rest free of predation and any of the flow impacts. And so these have been tried on some of the intakes in the Sacramento River, and they're being evaluated as part of the project, but no conclusions have been drawn.
All right, thanks, Phil. I think Juliana, back to you.
Great. So thanks so much. Remember, you can type questions into the text area. Let's turn to Gardner Jones now, and he'll review the operational criteria. Gardner works with the Aquatic Resource Program Manager at Department of Water Resources. Thanks.
Thank you, Juliana, and good evening, everyone. So as noted, I'll do a brief overview of the proposed North Delta operations. The Delta Conveyance Project proposes new North Delta intakes, which will have new operating criteria. These operating criteria will be in addition to existing Delta operating criteria and regulations. Notable existing Delta regulations include, but are not limited to, Delta outflow requirements, such as those established by D1641 export to inflow ratio. The DCP will be accounting for the North Delta diversions as part of the export term. D1641 is part of the State Water Board management of water rights intended to protect agricultural and fish and wildlife beneficial uses in the Delta. There are also existing Old and Middle River flow requirements and export limits, both of which are regulated by state and federal Endangered Species Act permits. And these are to minimize potential impacts on listed fish species due to Central Valley and State Water Project South Delta water operations. The most current requirements are based on the 2019 National Marine Fisheries Service and Fish and Wildlife Service biological opinions and the 2020 California Department of Fish and Wildlife incidental take permit for the State Water Project. The new North Delta diversions, or NDDs for short, would operate in coordination with existing South Delta diversions. This is a concept known as dual conveyance operations. The potential flexibility in operations would be greatly enhanced by using either South or North Delta intakes. Current assumptions for the dual conveyance approach are to use the NDD to augment excess flow diversions on top of the permitted diversions at the South Delta intakes. This would mainly occur in the winter and springtime period. The NDD would also be operated to manage salinity and realize potential carriage water savings, mainly in the summer-fall period. Overall, the goal will be to maximize benefits while minimizing impacts. Here I want to orient you to the parameters developed to govern proposed NDD operating criteria or rules, as well as some key reference locations in the proposed intake region. As I introduce the components or layers of NDD operating criteria, I will also point out some of the biological rationale underlying their development. Inflows, identified here as Freeport flow with the red star, would be measured above the intake reach, which is shown here in light purple. Sacramento River flow downstream of the intakes, shown here with a green star, represents bypass flows, or the flow required to remain in the river. Sacramento River downstream of Georgianish Slough, shown here with an orange star, is also an important location in managing for tidal reverse flows, or times when tidal energy overpowers the river and water flows upstream during a flood tide. Now for the proposed NDD operational parameters. Fish screen approach and sweeping velocity criteria are requirements on how fast diverted water can move into and past the fish screens, respectively. This is to minimize near-field operational effects on vulnerable fish. Bypass flows are proposed requirements on the flows remaining in the river and bypassing the diversions. This is mainly to protect survival of fish migrating in the intake reach and through the delta. Pulse protection is a rule intended to further reduce diversions during key winter flow pulses when larger concentrations of migrating winter run Chinook salmon juveniles have historically been shown to move down the Sacramento River. Low-level pumping is the lowest identified diversion level and is intended to further reduce operations such that they have no or only minimal effects. This diagram attempts to illustrate a conceptual model for the NDD operating criteria. On top, we show a basic concept for fish migration through the proposed intake reach. Moving through time, I show assumed background numbers of fish in the river, shifting to a large number of fish and then back down again. Fish migration tends to be concentrated during a portion of the year, usually in the winter and spring, and is typically focused on short periods. For example, when young or juvenile Chinook salmon move downstream in response to environmental cues, like changes in flow and temperature. Hopefully this resonates based on what Mike presented earlier. On the bottom of the slide, we show the concept of layered protections, which the proposed NDD operating criteria are intended to provide. Approach and sweeping velocity criteria would minimize potential effects near the screens, while low-level pumping would limit potential diversion effects at the screens as well as downstream from them. Bypass flow criteria would define allowable diversions based on background presence levels of target vulnerable fish, like juvenile winter run Chinook salmon. Here we show the concept of early bypass flow protection, transitioning into pulse protection concurrently with the presence of a large group of winter run juveniles, then transitioning back to bypass flow protection once the pulse has passed. The pulse protection criteria would trigger based on storm-driven flow spikes to provide further protection during periods when larger concentrations of emigrating winter run Chinook have historically been observed. Fish screen approach and sweeping velocity is really the first layer of criteria operating at the screens themselves. As noted earlier, approach velocity is the velocity of water perpendicular to and going into the fish screens. Sweeping velocity is the velocity of water parallel to and going past the fish screens. Approach and sweeping velocity criteria have been established by the National Marine Fisheries Service, California Department of Fish and Wildlife, and the U.S. Fish and Wildlife Service. These criteria are to minimize potential harm due to entrainment, which is when fish are diverted with the water through the screen into the intake, and impingement, which is when fish contact and can be held against the screen through the force of the diversion. The DCP proposed project currently assumes an approach velocity of 0.2 feet per second, which is consistent with criteria used to protect delta smelt and lower than the 0.33 feet per second criteria used to protect salmon fry in upstream locations. The DCP also assumes an average downstream sweeping velocity of 0.4 feet per second, or double the approach velocity. So the figure on the left is a reminder of some of the key elements used to establish bypass flow criteria. As mentioned, bypass flow is the flow remaining in the Sacramento River downstream of the proposed North Delta diversion intakes. The criteria are designed to minimize upstream tidal transport or the reversing of the river flow back upstream due to diversions as well as incoming tides at 2 points of control: Sacramento River upstream of Sutter Slough and Sacramento River downstream of Georgiana Slough. These have been developed to preserve movement and survival of listed fish in the lower Sacramento River. We have developed a preliminary set of bypass flow criteria. These criteria are used as input into the analysis of potential effects. We will then consider the potential effects and determine if any changes to the criteria are needed. The bypass flow criteria would identify a percent of Sacramento River flow that could be diverted at the new intakes. This percentage would increase as the Sacramento River flow increases. The predicted bypass flow would be determined based on daily average or tidally filtered flows. In wetter years, fish tend to do well. Fish species native to our region, such as Chinook salmon and delta smelt, have evolved to take advantage of periodic conditions produced when there is more precipitation in the system. To allow for the idea that drier years should have more fish protection, the bypass flow criteria have 3 levels that change for drier or wetter conditions for the period when listed fish would most likely be near the facilities, which is December through June. The criteria would change from level 1 to level 2 after 15 total days of bypass flows over 20,000 cubic feet per second, or CFS. The criteria would change from level 2 to level 3 after 30 total days of bypass flows over 20,000 CFS. And flows of this magnitude generally reflect the conditions associated with increased precipitation and typically occur in the winter and spring months. Under all levels, the North Delta diversions would not divert any water during low flow conditions, when the Sacramento River flow is less than a daily average of 5,000 cubic feet per second. As flows increase over 5,000 CFS, the new diversion would divert only low-level pumping up to 900 CFS. The flow range for low-level diversions varies. Under level 1, only low-level pumping would occur up to river flows of 15,000 CFS. Under level 2, only low-level pumping would occur up to river flows of 11,000 CFS. And under level 3, later in the season of wetter years, only low-level pumping would occur up to 9,000 CFS. As river flows increase further, the diversions would slowly increase towards the maximum diversion rate of 6,000 CFS. Under level 1, the NDD would reach 6,000 CFS diversion when bypass flows would be 26,285 CFS. Under level 2, the NDD would reach 6,000 CFS when the bypass flows would be 22,375 CFS. And under level 3, again, later in the season of wetter years, the NDD would reach 6,000 CFS when the bypass flows would be 18,750 CFS. We understand that when we talk about the proposed diversion facilities having a capacity of 6,000 CFS, it may sound like they would be diverting 6,000 cubic feet per second all the time. But these bypass flow criteria would limit the diversions to wetter periods when there is adequate downstream flow to meet regulatory requirements and maintain fish survival as they move through the delta. Pulse protection is intended to provide an additional layer of restriction on the NDD when storm-driven flow spikes, usually in the winter months, occur in the upper Sacramento River region. There is evidence that large numbers of endangered winter run Chinook salmon begin moving downstream toward the intake reach in response to these storm-driven flow pulses. Preliminarily, the project is proposing to implement pulse protection criteria up to twice per year to address major pulses of juvenile winter run migration. As noted, this approach is based on historical observations of juvenile winter run Chinook flow-driven movement patterns from upstream locations into the delta. The diagram again illustrates the pulse protection concept, where additional operational constraints beyond the bypass flow criteria are implemented when a large group of winter run are predicted to be near the intakes. Low-level pumping represents a diversion level with minimal effects to the river and aquatic resources. For low-level pumping, the DCP proposes from 0 or no North Delta diversions up to 900 CFS total diversions at the North Delta intakes, depending on flow conditions, with a diversion rate not to exceed 6% of Sacramento River flow. So for example, the low-level pumping maximum of 900 CFS could only be taken with Sacramento River flows at or above 15,000 cubic feet per second. Here the diagram highlights how pulse protection periods would reduce diversions proposed under the bypass flow criteria down to low-level pumping. This low-level pumping would further minimize effects to the river and to fish present near and downstream of the proposed intakes. This figure is used as an example to illustrate the proposed Delta Conveyance Plan operating criteria overlaid on historical flows from water year 2016. This is not modeling, but rather an example for how new intakes with a 6,000 cubic feet per second capacity and the proposed DCP operations criteria could have looked in 2016. To help visualize, a cubic foot is approximately a basketball-sized box, and the Sacramento River typically has thousands to tens of thousands of these moving past a given point every second. Flow in CFS is on the left, and date is shown on the bottom. The vertical color swaths moving across the graph represent the bypass flow levels, with level 1 in the earlier part of the year in yellow, level 2 further along in orange, and level 3 shown in green. You can see the progression through the levels over the course of the year and the Sacramento River hydrograph. vertical light blue bar in the late December period represents a triggered pulse flow event. The solid blue line moving up and down through the graph is Sac River flow measured at Freeport, while the dotted blue line tracking it is bypass flow. Finally, the red line near the bottom of the graph represents the resulting North Delta diversion flow levels. Based on this example year, there are high flow periods with potential sustained 6,000 CFS diversions, interspersed with lesser intermediate diversions, as well as low-level pumping for extended amounts of time. Thank you.
Thanks so much. So we've had a couple of questions for you, Gardner, on your presentation. So Carrie, do you want to go through those questions?
Sure. There have been a number of them, so we probably won't get through all of them, but I did want to just remind people that we will issue an FAQ after the meeting for any of the questions that we don't get through. And we will be issuing one from the first meeting as well. It's just not quite up yet. So Gardner, in one of the earlier slides, you had mentioned you had a graphic that had low-level pumping, and it looked a little bit like low-level pumping would be occurring all the time. And then later in the bypass flow chart, or in the bypass flow table, it did not look like it would be occurring all the time. Can you elaborate on whether low-level pumping would occur all the time?
Sure. So low-level pumping would be, again, the lowest level of diversions allowed at the North Delta diversions. They would not be in place all the time, although keep in mind that low-level pumping includes potentially zero pumping. So from that perspective, you could consider them always, there's always a degree of low-level pumping. The main point, though, is that with average flows in the Sacramento River below 5,000 CFS, there would be absolutely no pumping. So hopefully that helps a little bit.
Thank you. Then can you clarify if the bypass flow, approach velocity, and sweeping velocity numbers that you provided are average, daily, or instantaneous values?
There's the approach and sweeping velocity criteria, and those have been identified and are, generally speaking, instantaneous requirements. The bypass flow criteria, on the other hand, that next layer of criteria, those are operating on a daily average basis.
Thank you. And then, do juvenile fish move with flow? Do they tend to collect on the outside of river bends?
We can definitely expand on this later. It depends a lot on the species of fish. The collection of juvenile fish on the outside of bends, I'll assume is talking about downstream migrating Chinook salmon or salmonids. And I think the understanding is that acoustic tagging studies that have happened in the past that track movements of juvenile Chinook salmon as they move downstream have shown that generally speaking, fish do move with the higher velocities of flow, or at least they concentrate in their movements. But as far as collecting, I'm not sure exactly what is assumed there. They generally don't collect as in kind of stacking up and stay there, but rather stay with more flow.
Can you explain a little bit more about the term preliminary bypass flow criteria? People wanted to know preliminary until when and what the process is.
Yeah, that's a really good question. So the term preliminary here we're using basically through the development of the CEQA document and the application of our analyses to the preliminary or proposed criteria. And so they're preliminary in the sense that we're acknowledging that through the analysis and evaluation of effects that we get from that analysis, we may need to revisit the criteria. And so that's why, generally speaking, we use the term preliminary.
Yeah, I think that there is some concern that we might continue to change operating criteria sort of during project implementation, and that's not the case. It's just that we need to have a set of criteria that we look at to analyze fishery impacts. And so that's what we're putting into the input into the models, but depending on what the effects analysis says, we may update those but we would do that within the CEQA document. We're not going to continue to change them into project implementation. So Gardner, can we talk a little bit again about what each of these lines are? I think people thought that the blue lines may also be proposals.
Got it. Yeah, there is a lot going on here, so appreciate that. What is represented here, really the red line is an attempt to illustrate what a 6,000 CFS capacity project operated under the proposed operating criteria would produce in this water year. So again, it's not modeling, but you just take the flows that we historically saw here. So those flows are shown. The Freeport, Sacramento River at Freeport flows are that blue line that's kind of starts below 10,000 CFS and jumps up. It jumps up coincident with that first pulse protection, so that light blue bar, and then it continues to kind of move through time, and you can see how various precipitation events or prolonged precipitation events produce greater flows as it moves through time, going through. So as you see on the bottom, December, we got some big flows here towards the end of January into February, and then towards the April, and then coming into the spring period, flows were still in the 20,000 CFS range, but dropping down as they headed into the June timeframe, around that 10 to 15,000 CFS. So that main blue line, that's what historically occurred. That's the Freeport flows that, from the gauging station, for example. The dotted blue line, hopefully people can see that. That's when we're talking about bypass flow criteria. That's applying that so that you maintain, based on those bypass flow criteria, that's what you would maintain. In other words, instead of that blue line, what you would produce is that dotted blue line if you were to divert at the levels that the red line is showing. And that's consistent with the proposed North Delta operations. I just want to make sure people understand. So we're really only showing one application here, 6,000 CFS capacity with proposed criteria that we just gave an overview of. So hopefully that helps clear things up. I do want to emphasize this is not modeling. And so, for example, like other criteria are not captured here. So, if there were constraints for other reasons in the system, those would not be shown here.
Thanks. I think maybe just one more. So one of the questions was, will the rates of allowed diversion be stated as instantaneous values or average daily values? And I think that maybe reflects a little bit of difference, that we're not really necessarily establishing a rate of allowed diversion, but rather a suite of criteria that we have to meet in the system. So maybe you could explain that a little bit.
Maybe just to expand a little bit on what you said, which I thought was a really good way of describing it. So the criteria that we're talking about are basically, they operate at different, so the bypass flow criteria, as I said, that criteria is operating at a different time scale. So the daily average is trying to take into account the fact that there is, while you might have, a set flow over a day, there are tidal variations. And so that's tidally averaged out as far as what the criteria requirement would be. The flow requirements, as noted earlier, or the approach and sweeping velocity criteria, as mentioned earlier, those are things that would be, the idea is that those are happening at the screen and are therefore, again, requirements of what the facilities would need to maintain. And so they would need to operate such that we do not go over, for example, as we're showing preliminarily here, a velocity, an intake velocity rate of 0.2 feet per second. And so hopefully that helps, again, give a little bit more context to the idea of the layering of these criteria and how they are operating at different scales, both in time and space, right? So to try to capture effects in the river overall, as well as very near field, so right at the screens themselves.
Great, thanks, Gardner. Juliana, back to you.
Great. So we now have time for some verbal questions. If we get to all the verbal questions and there's still time left, then we can revisit some of the written questions that the DWR hasn't been able to get to so far. So please keep in mind that these are clarifying questions that will help you review the draft environmental impact review. These webinars are a chance for you to ask questions so that you understand the technical information, so that when the draft EIR comes out, you'll understand the technical background better. So if you have any question on the content covered this evening, raise your hand and I'll place you in a queue. You can raise your hand by clicking on the raise icon hand at the bottom of your screen. When I call your name, we'll start the timer for 2 minutes, and you'll have 2 minutes to ask your question. You'll have to unmute your question, your raised hand. You'll have to unmute yourself when we call on you. For those of you who are participating by phone, press 9 to raise your hand and 6 to unmute yourself. Let me check and see if there's anybody who has their hand raised, and we'll call on you in the order in which you raise your hand. So Deirdre Desjardins.
Thank you. Deirdre Desjardins, I was participating in the DCA's stakeholder engagement committee meetings when Phil gave the first presentation on the intakes, and he said that the Department of Fish and Wildlife had already determined the intake configurations and that they would be 3,000 CFS intakes, and that those were, and I'm wondering what process that was.
Who's the question for, Deirdre?
It's for whoever, but we were
Okay.
told that the intake configuration had already been determined when that it would be 3,000 CFS intakes,
Got it.
and the location had been determined by Fish and Wildlife before the stakeholder engagement committee met, and I'm wondering what process
Thank you.
that was
Got it.
determined by the fish agencies.
Thanks so much. Carrie.
So I can get that started, and then I'll hand it over to Phil. So I think that we probably need to clarify that. I don't think that what was being said was that DFW determined an intake configuration, but rather that DWR, as part of our notice of preparation, identified that we were going to have 2 3,000 CFS intakes. So as the DCA was designing the intake facilities, that was sort of part of the project that they were given to design. And I think the other piece was that there was information that was used from past efforts through California Water Fix, where the fishery agencies were involved, but not making decisions, just providing input and feedback. So Phil, maybe you can provide more detail on that.
Yeah, I think you pretty much nailed it, Carrie. The stakeholder engagement committee, obviously there's a bunch of alternatives. So when we made the presentations, we confined ourselves to the proposed project that was in the NOP, which was the 2 intakes at 3,000. But there's obviously the whole range of intakes from project capacity from 3,000 to 7,500. That includes 1 to up to 3 intakes. But we did present just the 6,000 at 2, just to get feedback and show, but we did show all the different sites to the stakeholder engagement committee to clarify where we were going. And I think Carrie was absolutely right. In the discussions, the analysis of the intakes did take into account the analysis that was done on the previous project to evaluate the sites. We did a completely new evaluation, but the reach of the river we're looking at, there's only so many sites available, and ended up coming to essentially the same conclusions as they came to in the past, which actually I think is shows that the work has been done pretty well under both studies.
Great, thank you. It looks to me like there's 3 people online who are just phoning in. If you want to ask a question, remember to press *9 and then *6 to unmute yourself. So next in the queue is James Cox.
Yes, can you hear me?
Yes.
Okay, my question is, what do you plan to do about Clifton Court? Are you going to screen? Are you not going to use it? What is your plans for the Clifton Court facility?
So as we were talking about earlier, what we're talking about tonight is really focused on the Delta Conveyance Project. And I know that this is often the source of frustration that we aren't sort of addressing all of the known potential issues in the bigger water system, but we really are trying to take a bite of those issues, sort of the subset that we think we can tackle with this project. So as part of this project, our objectives are to look at diversion and conveyance facilities to address state water project supplies in the long term. Looking at issues at Clifton Court specifically related to fish are not part of this effort.
Thanks. Next in the queue is Gabriel. Next in the queue is Roger.
My question is on the fisheries. The presentation indicated that you were going to get incidental take permits from the Department of Fish and Wildlife. Those incidental take permits pertain to threatened and endangered species under the ESA. And then part of the presentation also said that we're going to create self-sustaining fisheries. Now, the problem is here that you're going to take threatened species and then you're going to make them self-sustaining, whereas they shouldn't be just self-sustaining. Those populations should be robust. And it's very bothersome to me that the goal is just to have enough fish so they don't get extinct or get listed as threatened or endangered species. Thank you.
Thanks. So the incidental take permit is a way to comply with the California Endangered Species Act. And so what we would be doing as a project proponent, similar to other projects that would need to comply with the California Endangered Species Act, is that we would be submitting an incidental take permit application to discuss the potential effects of our project and identify mitigation for those efforts. And then the DFW would consider it and potentially issue an incidental take permit. I think that I did want to draw a distinction. You know, our effort is really focused on the effects of our project. There are many other efforts ongoing through the fishery agencies to restore and protect those fish. Our focus is on what types of effects our project could have. But I would like to turn that over to the fish folks. Mike or Maren, do you have something you'd like to add to that?
Yeah, this is Mike. No, you explained that well. Through the process of developing permits, if there's an identified potential effect to a listed species, if it's a state listed species, then the California Department of Fish and Wildlife Service will issue take authorization for those state listed species. And then, similar process from the Federal Endangered Species Act side of the world, we will get biological opinions from the U.S. Fish and Wildlife Service and or National Marine Fisheries Service, where we will ultimately have any take authorization if there's any determined potential impacts to federally listed species.
Thanks. Steve Starrett is next in the queue. Yes.
My question probably doesn't really pertain to everybody here, but I want to know when California is going to look about 50 miles to the west and see an unlimited supply of water. None of this we're wasting our money on is going to survive 100 years from now and supply enough water. There are many countries around the world with far less water than we have who survive very nicely on desalination. And until California stops spending money on moving water and starts making water and maybe new storage facilities, we're going to be arguing about this forever, long after all of us are dead and gone. So that's my point. I'm just getting really tired of this.
Next in the queue, we have James Hoffler.
Okay, so I really like this little timer thing spinning around. That's really cute. In the section where there was some discussion of the different types of screens, the underwater cylindrical screens were described as being very quiet because the motors and other pieces of gear that move around to make noise are underwater. But of course, that would make noise underwater. And as we know, sound underwater carries a long distance. So I'm wondering if any consideration's been given to the potential impact on aquatic animals, in particular mammals, and the fish of that noise produced, and potentially even, depending on the frequencies emitted by that gear, could it cause some problems for boats passing by with their sonar gear?
So in the EIR, we will be analyzing the noise impacts of construction and operations of the facilities. But Phil, maybe you could elaborate a little bit more specifically on the noise produced during the cleaning of the T-screens.
I mean, I appreciate the point because there are considerations for mainly, I mean, they call it acoustic effects underwater. It's often attributed to like pile driving and things like that for damage to fish. And the fisheries guys can expand more on that. Really, the noise issue on these screens is about the above water pulleys on the giant toothbrush. They're fine out in big agricultural areas, but we got people living across the river from it. So they're a little bit more of a nuisance. The sound levels for these motors and the vibrations from them, even underwater, are almost imperceptible. They move very slow. They're highly, they're geared to the point where they're just not a large degree of vibration at all from them, and they have nice bushings for where the screens rotate against the manifolds and that kind of thing. Now, I can't say, I'd have to talk to the biologist specifically that we've done a detailed analysis, but the regulatory agencies are highly enamored with these screens because of their the exact things we're talking about here, their rotation and cleaning underwater, and we have not noticed any kind of impact to fish. But again, I want to kind of defer to the biology people because they've done quite a bit of an evaluation about fish behavior around the different types of screens, and I don't think they see major differences.
Yeah, thanks, Phil. It's Martin Greenwood here. You're right in terms of that's not really been noted as an issue for specifically the screens beyond the sorts of acoustic impacts you were talking about during the construction being the main thing.
So if you have a further question, I just want to remind people to raise your hand again, and that will put you back in the queue. So Robert Kunde.
Thank you. So my question is for Mr. Jones. I'm talking about the operating criteria, and the examples you gave are focused on salmonids. That leaves the impression that the salmonid criteria are governing for operations, and that any criteria associated with delta smelt are that the salmon criteria would be more protective. But I could be completely misinterpreting this. So please comment on delta smelt criteria, if any, in relation to the salmon criteria and diversions.
Yeah, thank you, Robert. Appreciate that. So the approach and sweeping velocity criteria at the screens themselves were specifically developed for delta smelt protection. So those are at the level of what has been determined protective of delta smelt. So I did go through it relatively quickly, and apologies. That's maybe one of the main areas that we're specifically considering that additional level of protection above and beyond what would be for salmonid fry. And that's the 0.2 feet per second approach velocity as opposed to the 0.33 feet per second. As far as the bypass flow criteria specifically, which I think you were noting, generally speaking, some of the major things that we're looking at in developing the bypass flow criteria are the effects of diverting water on the potential for reversing flow. And we talked about it, or I talked about it very briefly, and so I could totally understand if it got missed. But essentially, we're looking at, it was developed to look at two specific points downstream at Georgiana Slough and Sutter Slough. And one of the main things there is the potential to affect movement of water, and to some degree, the assumption being that if there are, say, delta smelt present there, to what degree could that change their movement? So that is one of the it's more general aquatic effects, but delta smelt would definitely be a part of that consideration. And so that was one of the key considerations for bypass flow criteria specifically. I think that some of the other key reasons that I mentioned that the salmonids specifically is that there has just been a lot more research and a lot better understanding of flow and survival of especially juvenile salmonids in our system, so in the Sacramento River, and then even in the Delta or the lower Sacramento River intake reach. And it's where we have that information that we're using that and trying to apply it to the criteria and really to evaluate the criteria with that through that lens. And we just don't have that kind of detail for delta smelt. That being said, we are absolutely looking at what we think could happen to delta smelt based on those flow criteria and based on the stressors or the potential effects that have been identified for delta smelt as well as other fish species. So hopefully that helps a little bit.
Great. Okay. Arthur Feinstein.
Hi. So in 1993, I was the executive director of the Golden Gate Audubon Society. And in litigation, Golden Gate Audubon versus Browner et al., Carol Browner, who was the director of the US EPA, we sued over flows into the Bay Delta. And this is part of a process where the State Water Board was undergoing water quality plans for the Bay Delta, which allowed for pretty much very low flows for fisheries. And we were successful in getting the EPA to set criteria for flows that was, and they were considerably larger than Water Board's plan, but that was mooted by the Bay Delta Accord. But what came out of that whole process of litigation there and over the water quality plan at the State Board is a recognition that flows are the critical issue for the survival of salmon, delta smelt, etc. No matter how much wetlands you provide for them, it's the flows that are critical for their survival. So in your new plan for conveyance, what I'm suggesting is that you'll have to defend your water levels in the face of continuing science, except for ex-President Trump's abused science, that flows are critical and they need to be fairly robust, very robust, if these species are going to exist in the future. So that's for the scoping comments. You have said.
Let me just stop you there and have you get back in the queue. We'll start with flow. If there's any questions or comments on flow from any of the technical experts, and otherwise we'll allow you to get back in the queue. Carrie.
Sure. I think I can just mention that, as I mentioned earlier, the State Water Resources Control Board is considering options to update the water quality control plan for the Bay Delta. We are viewing that as part of the regulatory baseline. So if the regulatory baseline changes as part of that update, we would follow the revised plan. So we would be regulated by that change. So whatever regulation is in effect, we would need to follow it.
Thanks. Regina, do you want to unmute yourself?
Hi, sorry, can you hear me?
Yes.
Yes. Okay, I had a couple questions. One is I thought I heard it said that this was going to be operated under the 2019 biological opinion, which the state is actually litigating on that. And so I don't see how that is a good plan. It seems like a better plan would operate it to try to meet the doubling criteria and state laws. Because as you all know, we're dealing with like major winter run and spring run fisheries crises right now where we're losing the majority of the fish. So wouldn't it be a better plan to operate the tunnel based on recovery and doubling standards? So that's one of my questions.
Let me stop you right there so we can, if we'd stop the timer, and let me make sure that we get an answer to that. I don't want to have to keep too many questions in my head at once. Carrie, can you talk about the standard for?
Sure.
Yeah.
So under CEQA, we set the baseline at the time of the issuing of the notice of preparation, which we issued in early 2020. So based on that, we're using the standards and the regulations that are governing at the time that we're signing it, which includes the 2019 biological opinions. Many things could change over time, and we would continue to, as I mentioned with the state board, we would continue to follow whatever regulatory baseline is in place. But the reason that that's part of our baseline is because that is the regulation that was in effect and is still in effect. But I did want to highlight the difference between the environmental baseline and what we're looking at for our project. The environmental baseline reflects the conditions that are in the environment absent the project. And what we're looking at is then the change from that with our project. So we're adding protective criteria for our project on top of what is already being operated within the system.
Thanks. Regina, go ahead with your second question.
Okay, and there, it's kind of two questions, but one of them is a really quick one. One is, I was wondering what the bypass flow standards that you are trying to meet are, because those were mentioned, but what the actual CFS I did not hear. And then my other question is, other operations were brought up, and I have a question about cumulative impacts and how they'll be looked at with other projects, because, we're also having a proposal to put in Sites Reservoir, which would divert more water, and there's a lot of other operations going on. So how would you look at cumulative impacts and their impacts to fisheries?
Thanks so much. Carrie.
So the bypass flow criteria, one of Gardner's slides had a table that did have a summary of the criteria. The idea that when the river was below 5,000 CFS, all of the water needed to stay in the river, nothing could be diverted. And then from there, it deviates a little bit based on the conditions of the water year, but up to a certain amount of flow in the river, there could be low level pumping, and then up to a higher level of the river, it would ramp up slowly. So it is the CFS that we're proposing for an initial set of criteria are included in the slide earlier in the presentation. And then for cumulative effects, the way that we're analyzing cumulative effects is that we are looking at reasonably foreseeable past, present, and potential future projects. And we will be looking at the cumulative condition, whether that would have a significant effect on the environment, and whether the Delta Conveyance Project could be cumulatively considerable, could make a considerable contribution to that effect if it is in fact significant. So we're still working to identify the types of projects that would be considered reasonably foreseeable, but that is our approach.
Thanks. Is it Katie Wagner?
Hi, yes, thank you. I'm not a fish person or an engineer, but I wanted to know, so when you talk about these screens, is there a possibility that any fish will get caught up in the screens? And what's your acceptable threshold for that? How much percentage of fish can be sacrificed to these screens? How does that work? Thank you.
So Phil, I'm not sure if this is you or a Gardner or Mike question, but maybe you could get us started and we can have people add in.
Yeah, I don't think it's me as far as exactly which fish or what percentage of them are protected. They are the screen size recommended by all of the agencies with the minimum openings, and we actually do quite a bit. We're like half of the allowable for or double the allowable for open area. So the screens are quite they're more than compliant with the rules. I guess I would say that. Now, as far as where the rules come from relative to fish, I'd have to defer to the biologists.
So I think Mike can start us off, and Gardner may have something to add as well. So over to Mike.
Yeah, thank you. And I'm going to reference back to the development of the permits that will happen post the CEQA analysis. So California Department of Fish and Wildlife Service, as I mentioned, will issue take authorization as part of their permit. And that will, I mean, it's impossible to anticipate what that'll look like, but that may define a number or a percentage of, X species that could be lost before, operations need to be curtailed. That's an oversimplification of the potential process, but that's what it looks like. National Marine Fisheries Service would do the same for the species under their purview. If there are potential impacts to spring run, winter run, California Central Valley steelhead, green sturgeon, there would be a release of a take statement that would authorize a certain percentage of loss or take at a facility. And there would then be criteria that would occur based on when that may happen. And U.S. Fish and Wildlife Service from the aquatic side of things would do the same for Delta smelt. So that's how that would work.
And Gardner, did you have something to add on top, or did Mike cover it?
Both Phil and Mike, I think, did a great job. Maybe I'll just quickly say that, kind of from a procedural perspective, the proposed project, as Phil said, will use the criteria and the technology that the fish agencies require. And then our analysis, what we'll try to do is based on life stages and basically best available information we have as far as which species would be present and their vulnerability, we will analyze the proposed project, the proposed operating criteria, to look at to what degree that effect could happen. And that's really what the CEQA document will disclose, and then what the fish agencies would evaluate to say, yes, that you did a good job of evaluating it. It's, there's a problem, or that's too high, you need to mitigate, or you need to shut off operations or something along those lines. But where we are right now is just trying to implement kind of the best, best science to drive the proposed project. So the best criteria, the best technology, and then the most up-to-date evaluation to try to look at, okay, well, if you are operating that way, what are the effects to the fish? And so, for example, we would look at larval Delta smelt size and try to come up with some estimate of, if they are vulnerable, how many of them could be entrained. And that would be the type of information we would be evaluating to try to understand the impacts of the project.
Deirdre Desjardins, you just need to,
I just did it. It flashed on my screen. Thank you. I had two more questions related to the bypass flows at the intakes. The first is, why hasn't is DWR going to put a flow sensor there? Because there really hasn't been flow and velocity data gathered. And second, is DWR aware of the 1982 studies that were published of flow and velocity that were done for the original peripheral canal?
Thanks, Carrie.
So in terms of whether DWR is going to be considering a new flow sensor, I think that as part of the overall project implementation, if we reach that phase of the project, we would be developing a monitoring and mitigation plan. And so we would identify any necessary monitoring efforts that we would need. We're just not there yet. So I don't have an answer yet to that part of the question. In terms of the 1982 studies, I will say we have a large team, and I am not the only person who looks at that material. So I am not aware, but I think we probably are in the bigger picture, and we can certainly look into it.
So we have two more people in the queue, and I want to make sure we get to those before we end tonight. So James Hoffler.
Okay, I'm unmuted. Can you hear me okay?
Yes.
So this kind of follows up on something that Katie and Gardner referred to, the potential for entrainment. In regard to striped bass, they spawn in the open water of the river. And when the eggs are initially dispersed, they're pretty small, like 1.3 millimeters. And then when they're fertilized, they go up to 3.4. And then when the pro-larva striped bass actually hatch out of the little tiny egg, they're actually in a way kind of smaller, and they're very weak swimmers. So has any study been done to see what the potential might be for entrainment of eggs, or the larval stage of the striped bass into the screens?
So I think Gardner, Mike, or Maren, I think one of the three of you, but I'm not sure who to pick on.
I can take. This is Maren. Yeah, I mean, that's certainly one of the effects we have to look at. I would say, you know, not just striped bass, but any species that has the potential for, you know, any of the species that we identified that Mike showed, you know, in the presentation earlier. We need to identify which might be the vulnerable life stages that could be susceptible to entrainment. Consider the biology, consider the timing, obviously, in relation to when diversions might be occurring and those sorts of factors. So I think the basic answer is yes, we do need to consider that in our environmental analysis.
Okay. Patrick Porgens? No, I'm afraid we can't hear you. Carrie, there's a question from in the written commentary. Carol de Sacampos was asking, she understands how fish go upstream, but how do these different fish screens and mechanisms allow fish to go downstream?
So yeah, I think that would be a good question for Mike. So Mike, if you could, how do spawning salmon return upstream?
Well, I'm not sure I quite understand the specifics of the question,
Okay.
but
So let me try again. Sorry. So I think we've been talking almost entirely about juvenile salmonids and how we're providing protections for them, but we haven't really mentioned anything about adults and providing protections to allow them to go upstream. Could you sort of explain why that is?
Okay, well, the juveniles are, you know, weaker swimmers than adults. So presumably if you provide protection for the juvenile salmonids, the protections would be in place for the adults as well. You know, adults travel in a different behaviorally different than juveniles do. Adults aren't so concerned about predation the way juveniles are. Juveniles tend to hug a little bit closer to the shore than perhaps maybe some of the adults do. But really the crux of it is if you have the protections in place for the juveniles, it would be assumed that would be enough for adults. And that these screens won't be posing any fish passage issues or anything like that would hinder upstream movements.
Thanks. So if you have any questions that weren't answered tonight, please remember to send an email to the Delta Conveyance DWR page, and the DWR will be taking account of those questions and we'll be able to follow up. So I want to thank you for attending. The presentations are available on the DWR website, and they were also sent out this afternoon. So to view or download those, go to the informational webinars page on the Delta Conveyance section of the DWR webpage. Once you're on that page, scroll down to the topics, schedules, and registration section, and you'll find a link to the presentations under the header for this evening's webinar. Also, there's a video recording of this event, which will be made available on the Department of Water Resources website. So again, if you didn't get your question answered, or if you think of something after tonight, send an email to deltaconveyance@water.ca.gov. DWR won't be preparing individual answers to you, but they'll look at the common sets of questions and write frequently asked questions responses, and we'll post that as a document on the webinar page. I want to let you know that there's 2 more webinars coming up. August 25th is on climate change, and September 16th is on environmental justice. And those ones also will include all the materials. They'll be videotaped. They'll be simultaneously translated as well. So I want to thank you all for participating and sending in your questions. And please stay informed by following these different ways of staying informed that you see on the webpage. So thanks very much for your participation.